Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Fansuri, and today our group will be presenting our mini project. We repeat the death cause of air pollution. Our mission is we clearly articulates our commitment to reducing and preventing the emission of pollutant into the air. Our vision was to create a future where the air is clean and healthy, and communities and individuals are protected from negative effect of air pollution. And of course, our goals is to employ a range of strategies such as research and development of a new pollution prevention technologies to raise awareness about the importance of air pollution prevention. Alright, what is the meaning behind our big title? Air pollution is a serious global health concern that affects millions of people around the world. The tiny particles and harmful gases in the air we breathe can cause a wide range of negative health effects, from respiratory problems and heart disease to cancer and premature death. The death of air pollution is not only crucial to improve human health and well-being, but it is also essential for preserving the natural environment and preserving the quality of life for future generations. The introduction of comprehensive air pollution control measures and the development of clean technologies and sustainable practice can help to reduce and ultimately eliminate the global problem. Next, I will introduce our group member, which the first one is me, myself, Ahmad Fansur Akmal, the founder and the CEO of this project. Nur Ashraf Haikal Farhan as the head of marketing, Muhammad Fidos Aiman as program officer, Muhammad Lumat Hakim as managing directors, and our final members, Azri, as key consultants in this project. So, without further ado, we will proceed to the root cause identification. Farhan, the stage is yours.
Hi, my name is Nur Ashraf Haika Farhan, and I will continue for the next section, which is Pareto chart. So the title is Total Air Pollution, Death, and by types. So we can see two simple line graph, total air pollution, death, and air pollution death by type. And we have indoor, outdoor, and ozone. So air pollution death refer to the number of deaths caused by exposure to polluted air. According to the graph, the total number of deaths caused by air pollution decreased significantly from 1990 to 2015. In 1990, approximately 110,000 deaths were caused by air pollution, while in 2015, that number had reduced to below 70,000 deaths. Next, we have indoor air pollution death per 100,000. Based on the pie chart, indoor air pollution death per 100,000 people have decreased over time from 1990 to 2015. In 1990, there were 15,800 dead people, which decreased to 14,500 deaths per people in 1995. This trend continued with 12,800 deaths per people in 2000. Next, 11,100 deaths per people in 2005 to 2005 and 19,600 deaths per people in 2010. The lowest number of deaths per people occurred in 2015 with 850 deaths. So next, we have outdoor particulate matter pollution death per 100,000 people. Outdoor particulate matter pollution death per 100 people have decreased over time from 1990 to 2015. In 1990, there were 8,390 deaths per people, which slightly increased to 8,610 deaths per people in 1995. However, this trend saw a decrease with 8,400 deaths per people in 2000. Next, 8,170 deaths per people in 2005 and 7,800 deaths per people in 2010. The lowest number of deaths for this pie chart per people occurred in 2015, which is 7,410 deaths. For the next pie chart, we can see outdoor ozone pollution death per 100,000 people. Outdoor ozone pollution death per 100,000 people have decreased over time from 1990 to 2015. In 1990, there were 930 deaths per people, which decreased to 890 deaths per people in 1995. This trend continued with 830 deaths per people in 2000, 750 deaths per people in 2005, and 680 deaths per people in 2010. The lowest number of deaths per 100,000 people occurred in 2015 with 660 deaths.
The 5 whys. The 5 whys technique is a problem-solving method used to identify the root cause of a problem by repeatedly asking why a particular issue is occurring. The technique is often used in quality control or process improvement effort and is based on the idea of most problems can be tracked by their underlying cause and asking why the problem is happening and ask again why for each answer until the root cause is identified. This technique is also called the 5 whys. So the 5 why technique. The first one is why is death by air pollution happening? The second one is why are people exposed to harmful particles and gases? Third, why are these emissions happening? And next, why are the regulation and enforcement from the government is weak? And lastly, why is there a lack of political will to tackle about this issue? Next, the reason behind the 5 whys. The first one is why is death by air pollution happening? So the explanation of the reason is air pollute release a variety of pollutants into the air. Long-term exposure to this pollutant can lead to a variety of health problems such as in respiratory cardiovascular disease, which can be fatal, including men and women. Second, why are people exposed to harmful particles and gases? Industrial activities such as manufacturing, mining, agriculture can release pollutants into the air, such as transportation from cars, trucks, bus, airplanes, and others on, which this also contribute to the air pollutants. The third reason why this happened is why are these emissions happening? The emission happening because it's primarily from human action itself, which is burning of fossil fuel for transportation, power generation, and industrial process. The use of fossil fuel to power cars is one of the major source of problem for air pollution. And next, why are the regulation and enforcement is weak? In some cases, political leaders may prioritize economic development over and job creation over environmental protection, and this may resist implementing strict regulation or enforcing existing law because the economic development is very important for the country growth. And lastly, why is there a lack of political will on why the air pollution is happening? These are many reasons why there may be a lack of political will regarding air pollution. Some of the factors that can be contribute to this complexity of the problem is the lack of public awareness and engagement and competing priorities over interests. So I think that's all from me. Thank you very much.
For the next slide, we have fishbone diagrams. Air pollution can be divided into several types, including indoor air pollution, outdoor particulate matter pollution, and outdoor ozone pollution. First, indoor air pollution refers to the presence of harmful substances or particles in the air inside homes, offices, and other buildings. For example, we have second-hand smoke, radon, volatile organic compounds, and the use of coal and wood-burning stove. Next, we have outdoor particulate matter pollution, which refers to the presence of small particles in the air outside, such as dust, dirt, and soot. For example, industrial emissions, natural sources, or we can call dust storms, and vehicle exhaust. Last but not least, outdoor ozone pollution refers to the presence of high levels of ozone in the air outside. High level of ozone can be harmful to human health and can damage crops and other vegetation. For example, for outdoor ozone pollution, we have pollutants for cars, power plants, and other sources react with sunlight.
Okay, for the next is PDCA. So PDCA is plan, do, check, and act. So first, what do we plan? We plan to prevent air pollution indoor or outdoor environment. And then, we prevent exposure of nitrogen dioxide can aggravate respiratory disease like asthma. So next, what do? We avoid smoking indoors, reduce number of people that smoking, and avoid open burning. And for check, the attitude of smokers who are difficult to quiet smoking. And second, recommend other method than open burning. And third, implement the dangers of pollution at the beginning of the school. So for act, we plant trees for filtering pollutions and absorb carbon dioxide. Second, limit backyard fire in the city. And third, switch to electric or hand power lawn equipment. Okay. Next, FMEA, failure mode and effect analysis. Okay, for first process that we choose is conducting awareness campaign, which is severity 2, probability of occurrence 4, probability of detection 7, and list of reference number which is 56. Second, promote use of electric vehicle, which is severity 2, probability of occurrence 9, probability of detection 9, and risk reference number is 162. For third one is make sure everyone is aware of dangers of smoking. Severity 1, probability of occurrence 9, and probability of detection 7. Risk reference number is 63. So for fourth is maintain air quality for certain places. Severity 3, probability of occurrence 7, and probability of detection 6. Risk of preference number is 126. And the fifth one is enforcement of air pollution laws, which is severity 4, probability of occurrence 6, and probability of detection 5. And risk preference number is 120. And the last one that we choose is change smoker attitude, which severity is 2, probability of occurrence is 10, probability of detection 10, risk preference number is 200. Next is potential solution. Mini project that we run is the dead cause of air pollution. We list 6 pollution that can help the country decrease the air pollution, just like I mentioned just now. So from the table of every potential solution is number 6, which is to change smoker attitude. This is because smoking is number 1 causes of air pollution in this country. Otherwise, we can change technology that cause air pollution, but we can change people attitude to reduce the number of smokers, decrease air pollution in this country. So that's all from me. Thank you.
So for the next slide, we have dashboard. This is dashboard for our group, and everything record, statistic, and data for air pollution that will be present is this dashboard. So we have 6 graphs. For the first graph, we have total air pollution depth from 1990 to 2015. So next we have air pollution depth per type, and the type is indoor, outdoor, and ozone. Two of two of this graph is a pie chart. So for the next graph is a bar chart. For the first graph, we have air pollution depth per type, and the type is indoor, outdoor, and ozone, and it will be present in number of deaths, number of peoples. Next, we have indoor air pollution depth per 100,000 people, and this graph also will be present in number of peoples. Next, we have outdoor particulate matter, that's per 100,000 people. This graph also will be present in number of people. So last but not least, outdoor ozone pollution, that's per 100,000 people. So this graph also will be present in number of peoples.
Assalamualaikum warahmatullahi wabarakatuh. Okay, before we start with data analysis, which is using Anaconda, I will introduce myself first, which is my name is Muhammad Alman Hakim. Okay, for our main project, the topic we choose, which is air pollution, and the central idea, which is we target to worldwide that attribute to air pollution. Okay, right now that I present right now, which is the data analysis that we already do it. Firstly, we will start with a little bit description about this data. Firstly, this data set include 7 column, which is first column entity, which is contain the name of the country, and the second column code, which is it contain code of the country, and the third column, which is a year, which is years range from 1990 to 2017. And the fourth one, which is the air pollution, which is the total death per 100,000, which is the content total deaths. And next, which is indoor air pollution, which is death per 100,000, which is categorized to per 100,000, which is contained death due to indoor air pollution. And next one, which is outdoor particulate matter, which is death per 100,000, which is contained that due to outdoor pollution for the outdoor particulate matter. Which is the last one, which is the outdoor ozone pollution, which is same with the others, the others data, which is that per 100,000, which is that due to ozone pollution. That is the little bit description about our data, which is we have a 7 column. And next, which is the next step for my group, which is import relevant Python library, which is this normal when we want to start data analysis, which is using a Jupyter notebook. Which is we import the library, which is such as NumPy, Pandas, Matplotlib, which is Seaborn, and others Python libraries. That is the first step for our data analysis. For the second step, which is we connect with our Excel file, which is, as you can see, this coding, which is connect with our Excel right here that I'm showing right now. And that's the coding, which is to connect with our dataset Excel. And next one, which is briefly, we want to see how many data which is in this dataset and column, which is this is a description to show overall of this dataset. You can see here 7 column in the overall data, which is 6,468. And next one, which is we want to see the head level, which is start from 0 and 2, 4. You can see here line 0 and 2, 4, which is this is the coding to show the early data set, the early data from our data set. And you can see here that all of the data already normalized in a depth per 100,000 format, so it should be easy to compare. And next, which is this is a coding for to see dataset shape. As you can see at the right one, which is the 7 code. The 7, which is a column, and the left one, which is uh, data inside the data set, which is the total 6,468. Okay, the second step for the data analysis, which is uh, okay, for the second step, which is in our data analysis, we need to cleaning our data first, which is data cleaning. For the first step, which is we need the info for our data set. As you can see here, there is 7 column, which is there is overall 6,468 data that already in entity, and but in code there is a 504,088, which is there is a missing value in code column, and the other which is data type and the count not none, which is other S. Okay, the next one, which is the coding, we need to know how many missing value in each column, which as you can see here, there is a missing value in code column, which is the total 980. And the way we clean this data, which is uh, the only column missing value is the code column, and which is column contain a 3 character country code, which is example one, such as Argentina country, which is the code which is ARG. As you can see here in our Microsoft Excel, Afghanistan, and the code which is AFG. And everything is not important, but because just using code to shortcut the country name. And this missing value should be easily addressed. And before this step, what to do for the missing value, we will review which country have a missing code. And next, which is we filtering the data set to only row which have missing code value, then viewing each unique entity value. As you can see here, we see that the row missing a code value are not countries at all, but sometimes a rather different categorization of other country in dataset. We see to clean this data, this row should be moved into their own dataset, as including them will result in counting the same observation multiple time. And first, we should first manually create list containing relate to entity values, and we include the region, constitute countries for the UK, income, and SDI for the city index. You see the region we include this here, the region that we include, and constituent of the country, England, Netherlands, Ireland, and Wales. The income, which is for high income Asia Pacific, and for SDI, which is high the city index, which is high SDI, high middle, and low middle, and low. We classify it with this list identified, and we can proceed to copy them into their own data frame, and we drop the code column which is not applicable to these entries. See, as I said before, this is the code column which is not necessary because it's just a code to identify the country, and we clean data which is categorized with region, constituent country, and income, and set the city index. For next coding, which is firstly we create a new data frame for the different region, which is in entity, and next one, which is we drop the code column, and after that we create a new data frame for the constituent countries, and after that we drop a code column again, and it's the same with other categorization with high income countries and SDI levels. With the value extract, and we can copy the original data frame and drop all rows with missing value, and this will leave us with data frame containing a row only for individual countries. Okay, for the next coding in line 12, which is we summing the number of missing value for each data and adding those value together, which as you can see here, the coding which is to know the total number of missing value, and the total number of missing value right now currently have which is 0, And right now, our data is now clean and organized. And next, we can continue our analysis with EDA, which is exploratory data analysis. Okay, for the third step, which is EDA, it is the process of visualizing and analyzing data to extract insight, which is the first one. As you can see, just a reminder for the starting visualization, which is to initialize the info first. As you can see here, we know our column and data set. And next, which is describe, and this is the same at the top early. And describe, which is we know the count, mean, and standard value, mean and 30, 25%, 50%, 75%, and max value for each column, which is year. And for the for the each column, we can know how many value for each count, mean, standard, mean, and other as data in this coding. And next, we will start with our visualization, which is firstly we start with simple line graph of total debt and debt by air pollution type. As you can see here, for the left image, which is for a total air pollution debt start from 1990 to 2015. As you can see here, we can see a clear reduction in worldwide debt attribute to air pollution. And the left one too, as you can see, for the indoor, which is from 1990, we can see is a decrease in our debt per 100,000 for the air pollution. And same with other outdoor and ozone. For the outdoor, which I can see here, little bit decrease, but as you can see here, but it's not it's not a big step, but still decrease in outdoor. But for the ozone, it's still the same from 1990 to 2015. But we can see a little bit decrease at 2000 to 2015. But if we see at a rough look, which is maintain the debt per one, okay, under 2000 at 2000, sorry, 10,000 debt per rate from 1990 to 2015 for the ozone. And next one, which is a visualization for the simple line graph of total debt and debts by a region. As you can see here, when we clean data, this is a categorization for each region. As you can see, this color, uh, relate to this religion. We can see all the region. Uh, some have a reduction and some have increase in that per 100k by air pollution. And that's it for the simple graph for total debt and debt by region. And next one, which is the heat map. And the heat map show which is from the correlation plot above, and we can infer that the total debt is highly correlated with indoor air pollution. Yes, and we can conclude for this visualization that indoor air pollution in CR 0.9 is the highly correlate with indoor air pollution. That's for the heat map. And next, with the graph bar, which is you can see there that the overall debt to pollution has been decreased from 1990 to 2017, and we can also identify the major contributor for which is total air pollution debt, and that due to indoor pollution and followed by outdoor particulate matter. As I said before, which is in the heat map, uh, the, the correlation with the indoor air pollution is the highest, and this graph show that indoor air pollution is the highest. Okay, next graph is a plot graph. As you can see here, uh, this this plot graph is categorized with air pollution, indoor air pollution, outdoor and outdoor ozone and outdoor particulate matter. And we see the air pollution first. For the air pollution first, for the overall country is as you can see here, we have a decrease from 1990 to 2015. Decrease in a lot of our death per 100,000 to below 60,000, which is uh, quite successful. For the next graph, which is indoor air pollution, is the same with the air pollution too, which is we can see a decrease that per 100,000 from 1990 to 2015, and the same with outdoor ozone pollution. But we can see is decreased to 1990 to 2015, but in 2015, which is this this duration, which is we can conclude that there is no increase in that that by outdoor ozone pollution. For the last plot graph, which is outdoor particulate matter, as you can see in this graph, you see there is a increase and decrease for the outdoor particulate matter. From the 1990 to the 1950, we have an increase a little bit for that by outdoor particulate matter. And overall, and we can see there is a decrease to 1995 to 2015, decrease in the outdoor particulate matter. And the next graph, which is as you can see here, we list a top 5 country with the most pollution that, which we can conclude that uh, firstly Papua New Guinea, which is the highest, and followed by Afghanistan, Oceania, and Central African Republic and Solomon Island. And this graph bar conclude that this top 5 country is the highest that by this type, this 4 type of air pollution. Okay, I think that is it for our data analysis with using Anaconda.
Alright, in conclusion, air pollution is a serious public health concern that contributes to a significant number of deaths each year. The sources of air pollution are varied and complex and include both natural and human-caused factors. The effect of air pollution on health can be significant and wide-ranging and include respiratory and cardiovascular diseases, cancer, and other serious illness. Addressing air pollution requires a multifaceted approach that includes reducing emission from industrial and transportation sources, improving energy efficiency, and increasing the use of renewable energy, and also promoting sustainable land use and urban planning. While it is crucial to have political will for the same, it is also important for the public to be informed and engaged in the issue, to raise awareness and demand action from their leaders. With concentrated efforts from government, industry, and individuals, we can make progress in reducing air pollution and protecting public health. I think that's all from our group. Thank you for listening.